Namaste. In the sequence on programming paradigms, one aspect that I have left out is the notion of specialized programming languages or specialized languages. So the idea is that all along we have been talking about languages which are capable of expressing any computable functions. What is called the von Neumann languages or even the Turing complete languages, which you can express any computation that you can express in any other language. Okay, so whether it is a Prolog or Lisp or any constrained languages or parallel languages, they are all computationally equivalent. Only, as I said, they give you a worldview which is appropriate to that paradigm. So in concurrent languages, you could actually visualize multiple processes acting simultaneously or concurrently and communicating with each other, which is something that would be very hard to do with the C or C++, any of these languages, unless you use explicitly threads or processes, and create them and communicate, which in which case you are actually going to a concurrent paradigm. Similarly, if it is a logical programming language like Prolog, you can visualize the world in terms of logical statements and relations and express that to do any of these computations. So there also we have equivalent of loops and conditionals and all that is there. So they are all equivalent in some sense. Then there are, so that gives the idea that there sometimes we know we are going to live with a very restricted world. So a classic example is dealing with the databases. So if you take a language like SQL, it is not a general programming language like C or Pascal or Prolog or Lisp or whatever. It assumes that your world is basically relational tables, okay, which satisfies the relational algebra properties. And so you want to deal with that as your world. What you will need is something to store entries into the table, to create the tables, define schemas, retrieve specific information, basically the select class of queries. So under various conditions, sort them, etc. But everything you are dealing with is relational tables, rows and columns, and where a row is typically a record and columns define the properties of that record. Pretty much like object or class definition, the properties being the columns and the different instances of that object becoming the rows in the table. So that gives us the language SQL, which I'm pretty sure all of you know about. Similarly, if you take something like a spreadsheet language, which is what is used in Excel and all, the world is viewed in rows and columns, but there is no longer the row being column being properties and row being instances. You can mix them anyway, part of rows or different information you can capture in different parts of the same spreadsheet. So there is a lot of flexibility that a spreadsheet gives, but there is very little you can actually do with the spreadsheet if you look at it. Basically, you can define relationships between cells or groups of cells, and that is basically the computation that Excel allows you to do, or any spreadsheet allows you to do. Similar, so when you want to deal with a particular domain and you know that you are going to deal with information of a particular type, you can actually create a sub-language. Like you can take C or any of these languages as the base, but you write an interpreter for that subset and deal with that. Now that interpreter becomes your compiler or interpreter, if you want to call that, and whatever that interpreter does is what the programming allows you to do. Another classic example of such specialized languages are expert systems, where the world is in terms of rules. So they have if then rules like if fever is there and it is more than 3 days and something, then this is the disease. So the entire world, entire knowledge is captured in terms of these rules. So what you need is a capability to read these rules and interpret them and use that to make detections. Nobody expects to do factorial or Fibonacci numbers using those. Using a rule-based language, for example. So there are various types of rule-based languages there. Similar, you can think of, for example, a graphic rendering language, which allows you to specify different graphic objects and then they should be rendered. Again, you are not looking at it as a general purpose language, but you want to specify different types of objects and specify their properties like their reflective properties, how much light will get reflected, how opacity and all those kind of properties. That is what you want that language to be to allow you to do. So special purpose languages were at some point in time very, very popular, and lots of such special languages had actually emerged. These days it's become much less because your languages have become very powerful, your computers are powerful. So possibly, and building abstractions using object orientation or the higher level constructs that are available possibly is easier. But it is a very important aspect of programming paradigm that you can create, you can visualize a worldview which is specific to your requirement and define a language which supports that worldview. And that is exactly the power of computing or computers as general purpose computing devices, or what the von Neumann structure. That if you look at even normal languages like C or Pascal, you are writing your program to solve a problem which we possibly has not anticipated so far. But the language and the system allows you to build such programs and present it to an external user. So you build an ERP system or you build a web portal or whatever. So these are all programs which for the external user, the user which actually uses the program actually sees it as a world. So when you are doing an ERP application, that ERP application is the world for that class of users. Right? And special purpose languages is taking it one step further, that instead of defining a full application and then giving it to the user, I'll define one layer on which he can define further applications. So when I build an expert system shell which is capable of reading rules, interpreting them, you can use those shell to define expert system for diagnosing headaches, or to troubleshoot devices, to machines, to make predictions on maybe investments or recommend investments. So all these different domains you can capture using that rule as your net capability. So it's a very interesting concept, and I think computing science students should understand this capability. So don't look at a language as an end in itself. The language can be used to define other languages, which itself can be used to define solutions. So from a language to a solution need not be a single step. Okay, and that's the concept of specialized programming languages. You can read up about any of these languages and maybe more specialized languages you can come across, and that is something that I would recommend that you do. Okay, so take care till we meet again.